So hi everybody, in this video we will be discussing about wave function and its properties. So wave function is a function in quantum mechanics. So this topic comes under understanding the basic of quantum mechanics. So I am Dr. A. L. Subramaniam, working as Associate Professor in Physics with SRM Madurai College of Engineering and Technology. So before understanding what is a wave function, first we have to understand what is a wave. So what's a wave? A wave is a disturbance which is traveling in a medium. For example, you just go to the pond and throw a stone. Then you might have created ripples which are waves in two dimensions. So what happened when you throw the stone? Some particles vibrated vigorously. Their height was increased from the surface level. So the variation of height of the particles has created these water waves. With an external disturbances, you created the height of some of the particles. You varied the height of some of the particles. So that is a water wave. So what about light wave? We know that light is an electromagnetic wave. It consists of electric field and magnetic field. And the variation in electric and magnetic field will give you the light wave. Now similarly in quantum mechanics we deal with microparticles like electron, proton, neutron. So they exhibit the dual nature. They can behave as particles, they can behave as waves. So when the electron or proton or neutron behaves as a wave, it can be described by variation in its wave function. So in general, these microparticle waves are called matter waves or de Broglie waves. So we can describe them with the help of wave function. So what's a wave function? Function in mathematics relates the variation in x coordinate and y coordinate. For example, I say y equal to 4x square, it can be a parabola. So here what is a wave function? It's a mathematical function. What is the purpose of this wave function? I want to describe the position of the electron. How will I identify the position of the electron? We have to find the coordinates of the electron x, y, z in 3 dimensions. And since the electron is moving, the time is also changing. So we have to identify the position of the electron with respect to a particular time. So I can say that the wave function psi is a function of x, y, z and time. So it's a mathematical function that relates the location of electron and time. I can find out what is the amplitude of the wave. If I know the position, the maximum displacement is amplitude. And if I know the amplitude, I can find the energy. Energy is proportional to square of amplitude. So in very simple words, what is the wave function? It's a mathematical function representing the position of the electron at a given time. Indirectly, it can also represent the state of a quantum system, such as electron or photon. It can also be related to other variables like spin of the electron, and it can describe the particle's behavior. So we all might have come across the wave function in Schrodinger's time independent equation, del square psi plus 8 pi square m by h square into e minus v on psi is 0. That psi is the wave function. So how is the wave function denoted? By psi. The Greek letter S after Schrodinger name. So now what are the properties of this wave function? First thing is the wave function must be complex. A plus IB. A is real part, B is imaginary part. The imaginary part represents the friction experienced as the electron is traveling through the medium. How can I write a wave function? Psi of xt, a one-dimensional wave function, is equal to psi naught e power I kx minus omega t. Psi naught is the amplitude of the wave, k is the wave vector or the propagation vector giving the direction of the wave, omega is angular frequency. Why the wave function is complex? It describes the dissipative forces. Now how to make the complex real? We have to multiply by its complex conjugate. So if I multiply the wave function by its complex conjugate, it gives me the measure of probability of finding the particle. So I say the probability is 0.5. There is 50% chance of finding the wave. The amplitude of the wave can be positive or negative. So if I just say that it is amplitude is minus 0.5, then probability has no meaning because probability is always positive. So how to make it positive? We multiply the wave function by its complex conjugate. So psi into psi star, psi naught e power I kx minus omega t. The complex conjugate is e power minus I kx minus omega t. If I multiply both, I will get psi naught square, the amplitude square. So larger the value of psi square, more the presence of the particle. Smaller the value, less the presence. Now the third important property of wave function is it must be single valued, because at one point it must have only one velocity, or the electron must be moving in a particular direction. So wave function must be single valued. The disturbance is continuous, so the wave must be continuous. The first derivative of the wave function will represent the momentum, so it should also be continuous and single valued because they are vector quantities. And one of the main properties of wave function is if I have an electron in a box, the probability of finding the electron is 1. So this condition is called as condition of normalization. So I find the integral of psi of xt whole square. The probability density, it must be 1. In one dimension, integral psi of xt whole square dx is 1. In 3 dimension, instead of dx, I will use volume element dv, it should be equal to 1. So on the whole, what is the conclusion? What is the wave function? It is a function which describes the behavior of the electron based on its position and time. What are the properties we can remember in simple words? It must be complex. It must be single valued. The derivative of wave function must also be continuous and single valued. The wave function by itself has no meaning. When I multiply by its complex conjugate, it will represent the probability density, and the wave function must be normalizable. So these are the properties of wave function. So thank you for watching this video.